A. It lists a list of potential differences obtained when metals P, Q, R, S, and T are used in the following electrochemical cell. So you have the metal, stroke metal ions in the aqueous state, and then salt bridge copper 2 ions stroke copper. Okay. Then we have the metal and the standard electrode potential. They are here. The first question is, what is metal R? Now when we look at our metal R, the standard electrode potential is 0.00 volts. So that is the reference electrode and it is referred to as hydrogen. So the answer is hydrogen. Is hydrogen. So the answer is hydrogen. Explain. Now the explanation is this. You put a semicolon like that, and then you say is standard. Okay, is standard value is equals to 0.00 volts. Or you can say is the reference electrode. So we are done with that. So metal R is which metal? Hydrogen. Why do you say it is hydrogen? Because the standard value of hydrogen is 0.00 volts. Or you can say it is the reference electron. Why do you say it is the reference electron? Because the electron potentials of other metals are measured in reference to hydrogen, which is 0.00. Are we together? We move to Roman 2. Which two of the above metals in an electrochemical cell will produce the largest potential difference? So with this, we'll now arrange all these metals in a number line, whereby we have said in the middle here we have 0.00 volts, and that one belongs to R. Okay? Now, using the number line, if we go to the right hand side, we have positive 0.45 and 1.16. So here 0.45 volts and then 1.16. 1.16. This is positive. Now going behind 0, we read 0.46 and then negative 1.1. So we start with negative 0.46 and then lastly negative 1.10 volts. All these are volts. Okay. Now positive 1.16 belongs to T. So this is metal T. 0.45 belongs to R. So this is metal S. Sorry. Yes, it belongs to S, that is metal S. Then 0.0 R, negative 0.46 Q, okay, and then this is P, like that. Now, the space in between is actually the potential difference, or the EMF. Are we together? The space in between this metal and this metal is the voltage or the EMF that is produced when you combine, for example, P and Q. Are we together? So for our case, the largest EMF will be produced by what? The one which is far right and the one which is far left, whereby the space in between is large. Are we seeing that? So here, so it will be what? P and T. Okay? The metals are what? Metal P and metal T. So this is the response. And this is how we got the response. By drawing the number line. Lastly, what would be the initial potential difference of the cell chosen in Roman 2 above? How do you calculate the EMF? Potential difference is what? Potential difference is the same as EMF, or the electromotive force. Are we together? So we say EMF is equals to what? Standard electrode potential in the right hand side we less standard electrode potential in the left hand side. So the right hand side we have P, which is what? Which is positive 1.16. We less the one which is on the far left. Are we together? Which is what? Negative 1.1. So we less negative 1.1. What do you get as our voltage? 2.26. So we get positive 2.26 volts. So that is what we get for that question.